This is lesson 9.1, Introduction to Oxidation and Reduction, or Redox reactions. So, oxidation-reduction reactions involve the transfer of electrons. And there's two easy ways to remember which is which. So, the first moniker that I like to use is called oil rig, which means oxidation is the loss of electrons and reduction is the gain of electrons. Some people prefer to use Leo the lion says grr. So for this moniker, Leo the lion, L for loss of electrons is oxidation, and grr, the gain of electrons, is reduction. So this is how you remember which is oxidation and which is reduction. So oxidation and reduction always occur together, and when oxidation and reduction occur, you have a redox reaction, meaning electrons are being transferred. So you determine the change by the change in oxidation numbers. So you determine what's being oxidized and what's being reduced based on their oxidation numbers. So there's some rules for assigning oxidation numbers. The first rule is that atoms in their elemental state, the one that you normally find them in, is always 0. For example, magnesium or oxygen or nitrogen or hydrogen, those would all be 0. In ions, the oxidation number is equal to the charge. So for example, in a magnesium ion, the charge is +2, so the oxidation number is +2. Same with oxide, 2-. Same with nitrite, 3-. All the oxidation numbers must add up to 0 in a neutral compound, and they all must add up to the charge on an ion in a polyatomic ion. Usually the oxidation number is the charge on the most common ion of that element. For example, sodium usually forms +1, oxygen usually forms -2, fluorine usually forms -1. Some elements vary in different compounds. For example, nitrogen, phosphorus, sulfur, the transition elements, they all can have different oxidation states or different oxidation numbers. So here's an example. Find the oxidation numbers of each atom in the following examples. So the first one, sodium. Sodium is just a solid, and that's how it's formed. It's an element, so it's just going to be equal to 0. Rule 1. Sodium chloride. Well, sodium is usually +1, so chlorine must be -1. Sodium sulfate. An easy rule to remember is oxygen is almost always -2, so that gives us -8 total. Sodium is usually +1, so that gives us +2 total. So that gives us +2 total. They have to add up to 0, which means sulfur must equal +6. So these are the oxidation numbers. In HNO3, O is -2 for a total of -6. H is +1, so N must be +5 because they have to add up to 0. And last but not least, in ammonia, hydrogen is +1 for a total of +3. Which means nitrogen must be -3 because they have to add up to 0. Alright, so we talked about this a little bit in your first year of chemistry because remember, when we name compounds with transition metals, you have to include this Roman numeral, and the Roman numeral tells you the oxidation number in that compound. So anything that has more than one oxidation number usually has a Roman numeral in it.